This is chapter 4, section 1, homework number 61. They want critical points and absolute extreme values, so absolute max and min. So critical points, we do need the derivative. And this is a product, so we do need to use a product rule. And that's not x, so that's a function, so that becomes box in our chain rule as we take the derivative. We first leave the first alone, take the derivative second. What's the derivative e to the box? I am my own grandpa times the derivative of box. Plus, you take the derivative first and you leave the second alone. Now you will notice they both have x's and they both have e to the minus x. So we're going to factor those out. We take two of the x's out because you take the smallest number between the exponents. And we take e to the minus x out. And what are we left with? So we took out two of these. There's one left. We took that out. So we have a minus x left. And we took the x squared out and e to the minus x, leaving a 3. And you can double check that by distributing, and you should get the original. Now we set this equal to 0. So we have x squared equal to 0, e to the minus x equal to 0, and opposite x plus 3 equal to 0. This is easy, 0. Got that. This is easy, 3. Got that. Here is where you have to know what this function looks like. E to the x looks like this. So you don't even have to graph e to the minus x because you'll notice it doesn't matter the x value. This graph never crosses the x-axis, therefore never equals 0, no matter what the exponent is, positive or negative. But if you want to graph e to the minus x, you can do that. It's just a reflection over the y-axis. That never crosses the x-axis, never equals 0. That has no solution. So we have two critical points, 0 and 3. Now maxes and mins occur at critical points or endpoints. So we need to find the y value at the endpoint, at the critical points, and at the other endpoint. Now again, this should make sense because there's only possible max and min points are those 4 points. So to find the max or min, I need to find the y value at those 4 points. And through the magic of my book, I can tell you the answers. This first one is going to be minus e. And what do you plug it into? Remember, you plug it into the original function. The original function tells you the y value. The derivative tells you the slope of the tangent line. You want the y value. You plug in 0 and you get 0. You plug in 3 and you get 27 over e cubed, which rounds off to approximately 1.344. And you plug in 5, and that's approximately 0.8422. So let's evaluate this now. Which one is the biggest? I claim that this is the biggest value. That is the maximum value, and it occurs when x is 3. And the minimum would be this, negative 2.7, and that occurs at negative 1. So if we take a look at this graph, I'm going to show you the graph of this. So the minimum occurred at negative 1, the max at the second critical point. Let's look at the actual graph. Here is the graph. Let me zoom in for you. Look at that. So we had a critical point at 0. And right there, you can see the slope of the tangent line is 0, but it's not a relative max or min. Our other one occurred at 3, and you can see that's the absolute maximum. And that's what we found in our work. And then the endpoints, that's not a max, but that is the absolute min right at that endpoint. So we found the absolute min and the absolute max from the graph, and that matches our work that we did.